Good morning, everyone. Today we're going to do one of our YouTube lessons for section 11.2. Still presumably stuff which you have mostly seen before on systems of equations. We're continuing on with systems of linear equations today. But we're going to move quickly from the 2x2 equations, which we were dealing with yesterday, into the 3x3 system of equations. A lot of the same principles hold true. Let me switch over to turn on my camera. By the way, I recorded this lesson yesterday. It stunk. I blundered here. I stumbled there. I did things the long way when I shouldn't have. And so I am re-recording it, which actually should make things go very smoothly. One of the advantages to doing a pre-recorded lesson is when you mess up, you can chuck it and start over. Okay, so yesterday when we had two lines, most of the time it seemed like they were intersecting in exactly one place. Well, if you have three linear equations in 3 dimensions, they're still called linear equations, but technically they don't form a line, they form a plane. I can have 3 planes which intersect in exactly one place. You are in a normal kind of room, the ceiling and 2 walls intersect in exactly one point. Now, you could have 3 planes which intersect in a line, and that happens. 3 planes which are completely on top of one another, an infinite number of solutions. Not that there aren't an infinite number of solutions here. This one, just like yesterday when we had 2 coinciding lines, we were going to say are completely dependent. And we could have a variety of different possibilities where we end up with no solution. There is no common point which is on all 3 planes in that first little bit in C, and there are no points which are on even 2 planes in that second example in diagram C. Those planes we would describe as parallel. Example 1 is one of those examples of a place where I didn't really read the instructions. I didn't do a great job on this one. I did a great job proving that 1, -2, +3 is the solution, but that's not what they asked. All they asked was to show that it is a solution. So what I'm going to do is I'm going to plug in 1, -2, and 3 here. 1 minus 3 of my -2's, so really +6, 1 + 6, and that's 7, plus 4 of those 3's, plus 12, 7 + 12 is 19. And I can do the exact same thing over here, where I got 2 of those 1's, and then -2, and then +3 is 3, and do the same thing for number 3, and I will end up with a -17. That's all they were really asking. However, since we've done it, and since we have to do it for other problems, let's go and figure out how I came up with the solution. And more importantly, with a 3x3 system of equations than other systems, smaller systems, is really keeping your work organized. So if you can see, by my original equations, I wrote a little 1, a 2, and a 3. Over here, I rewrote 1 just so I could follow my own work. I wrote a little 1 and rewrote it. Well, this is 4 times equation number 2. And so I ended up with 4 times 2x is 8x, 4 times y, and 4 times z. And what people often forget is the 4 times 3 is 12. Why did I pick times 4? Well, when I have a 3x3 system of equations, I have to pick one equation. I picked the middle one. To eliminate one variable, I picked z from the other 2. When I subtracted these 2 equations, I ended up with this, -7x minus 7y equals 7. Obviously, everything's divisible by 7, so I did. In fact, I divided by -7 and ended up with x plus y equals -1. I did a similar thing over here. I took 3 times equation 2 and equation 3, And I ended up with a new equation, which I called 5. By the way, this one over here was 4. And you'll notice that I eliminated z from those two equations. Now I have two equations, equation 4 and 5, both of which don't have a z. Two equations, two unknowns. That's exactly what we were doing yesterday. So I solved those. Once I found y, I plugged back in to find x. Once I found x and y, I plugged back in to find what z was. It turned out exactly what they had wanted us to prove, that it is 1, -2, 3. Yesterday I paused the video while we did the next one, so I will give you guys a chance to pause your video if you'd like, and get a head start on this guy. So hopefully we're back. I did roughly the same kind of thing. I looked at my coefficients and I said, okay, well, this guy has 1x, 2x, and 3x. Not real hard to multiply the first one by 2 and eliminate that, and then the first one by 3 and eliminate that. This one was a 2y and a y, okay, not too hard to eliminate, and a -3y would have been about the same amount of work. Z, not too bad to get rid of the z from equation 1 and 3, I just have to add them, but that 2 and that 5, I really don't like. I'm gonna have to multiply both equations by something in order to do that. So what I did was I decided to eliminate x. I multiplied equation 1 by 2. There is equation 2 as is. If you subtract, the x's go away. I did the same thing by multiplying equation 1 by 3 and comparing it to equation 3. Once I subtracted those, the x's went away again. And now I have equation 4 and 5, which only have a y and a z. As it turns out, I multiplied equation 4 by 5, and both of them now have a 20z in them. When I subtracted, things fell together pretty quickly. Once I found out what y was, I plugged it into this equation over here and figured out what z was. Now that I know what y and z are, I plugged back into actually equation number 1, looked like the easiest, and I found out what x was. Other ways of doing it, but that looked pretty straightforward. Okay. Well, a little bit of reading here says identify inconsistent systems of equations containing 3 variables. So I looked and I pretended like I didn't see that, and I went and I tried to eliminate x again. No, I tried to eliminate z, just adding these two equations together. Then I said equation 2 plus equation 3 will eliminate z in those two. And when I divided this one by 2, I ended up with x minus y equals 3. Well, I had x minus y equals 5 and x minus y equals 3. They can't both work. If you don't see that, subtract them, and I'll get that 0 equals 2. I'll remind you that 0 never equals 2. This never works. There is no solution. Okay. Finally, short video today. Finally, again, they say express the solution of a system of dependent equations containing 3 variables. So again, I pretended like I didn't see that. I went about my work and I ended up with 0 equals 0. When does 0 equal 0? Always. For any value of x, 0 equals 0. When x equals 5, 0 equals 0. So really I had my choice of what to put there for x, just like we did in the dependent ones yesterday. I also have my choice as to what to put to y. Doesn't make any difference. 2, 7 is my favorite ordered pair, so as an example, I chose those. But z, now I'm kind of locked in. So what I did was I solved that first equation. I could have solved any of those equations. They really are all the same thing. I solved one of those equations for z. And in doing so, I got that it is x minus y over 2. And one sec. You know, I was glancing at it and I realized I was repeating the mistake that I made yesterday. So that's no bueno. Scratch that. This is not a solution to it. If you want to see it, then plug in 2, 7, and 5 halves in over here, and it doesn't work. These aren't all the same plane 3 times. It's not completely dependent like that. They just form a line. So what I'm going to do instead is I'm going to say that my solution set contains any x. I'm going to skip just because of the way that I solved it. I'm going to skip and I'm going to solve for z in terms of x. So when I do that, I'm going to add z to both sides here, and I'm going to get negative x minus 6 equals z. So I'm going to say a negative x minus 6 over here. And then I'm going to have to solve for y in terms of x and, well, z, but x is also, or z is also in terms of x. So I'm going to say x minus y plus 2 of these negative x minus 6 is equals 0. I'm going to add y to the other side. That will tell me exactly what y is. I get x minus 2x, and it looks like a minus 12. That is a negative x minus 12, and so negative x minus 12 will go there. So in this case, once I've decided what x is, it informs me what y and z have to be. Let's see whether or not this seems to work. I'll pick 2 again for x. So if, just for example, the 0.2 comma negative 14 and negative 8 should work for all 3 of these. Let's give it a whir. 2 minus a negative 14, so plus 14, we're at 16, plus 2 of those negative 8s. 16 minus 16 is 0. Yep, it worked for that top one. And for that next one, 2 times 2, we're at 4, minus 14, minus a negative 14. Okay, so we're at 18 plus 3 of those negative 8s. So minus 24. I lost my place there. We're at 18 minus 24. And yeah, that should be a negative 6. Last one, same concept. 3 times 2 is 6. Minus 2 negative 14s plus 28. So now we are at 34. 34 minus 40 is negative 6. And yes, it worked out. Okay, so that is it. I think the homework which I assigned yesterday is actually not due until tomorrow. And that is our X, so I guess not until Friday. And that's the next time I'll see you. Have a good couple of days, and let me know if you have any questions. I will talk to you all soon. Bye-bye.